What is a polynomial? If the index of every variable in an expression is a whole number, then the expression is termed as a polynomial. Just to refresh your memory, whole numbers are 0, 1, 2, 3, 4, etc. Thus, 8x squared plus 5x plus 9 is a polynomial, as it has an index 2, 1, 0, which are a whole number. Let us see certain expressions which are not polynomials. Y raised to 3 upon 2 plus y minus 5. This expression is not a polynomial, as 3 upon 2, which is raised to y, is a fraction and not a whole number. M raised to 2 plus m raised to minus 1 plus 13. This expression is also not a polynomial, as minus 1, which is raised to m, is a negative number and not a whole number. Let us define the three types of polynomials. 1. Monomial. Monomial is a polynomial having only one term. Example, 5x squared, 37, minus 5x. 2. Binomial. Binomial is a polynomial having two terms separated by either plus or minus sign. Remember, if there is a multiplication or division sign between the terms, then it is not a polynomial. Example, 3x plus 5, 7 minus n. 3. Trinomial is a polynomial having three terms separated by only minus or plus signs. Example, 5x cubed minus 3x squared plus 7, 15 plus n cubed plus n raised to 5. Exercise 67. In this exercise, we shall now classify the following expressions into monomials, binomials and trinomials. X squared minus 2x plus 3 is a trinomial, as it has three terms. 8y is a monomial, as it has only one term. 2a cubed minus 5 is a binomial, as it has two terms. 3 minus 11b is a binomial, as it has two terms. 17m raised to 4 is a monomial, as it has only one term. 6n squared minus n plus 5 is a trinomial, as it has three terms. 35 plus x cubed minus 7x is a trinomial, as it contains three terms. 51 is a monomial, as it has only one term. 13 minus 8y cubed is a binomial, as it has two terms. 1 minus 4p squared plus 12p is a trinomial, as it has three terms. Exercise 68. In this exercise, we shall classify certain expressions giving reasons, whether they are polynomials or not. 1. b squared minus 25. Yes, b squared minus 25 is a polynomial, as the power 2 of the variable b is a whole number. 2. y raised to 1 upon 2 plus 18 minus 5y. No, y raised to 1 upon 2 plus 18 minus 5y is not a polynomial, as the power 1 upon 2 of the variable y is a fraction and not a whole number. 3. 7 divided by m minus 2. No, 7 divided by m minus 2 is not a polynomial, as we know 1 upon m is equal to m raised to minus 1. So the power minus 1 of the variable m is a negative number and not a whole number. Now let us learn the degree of polynomial. The highest index of a variable in the given polynomial is the degree of the polynomial. Example, in the polynomial x cubed plus 7x squared plus 5x minus 9, the degree of polynomial is 3, as 3 is the highest index of the expression. One more example, 27. Here, the index of 27 is not defined. It means that the index is 0. The degree of a non-zero constant monomial is 0. we shall now proceed to learn the meaning of the coefficient of a monomial. The coefficient of a monomial is the number before the variable in the expression. For example, 13m square. In 13m square, the coefficient is 13. For example, minus 5x upon 9. In minus 5x upon 9, the coefficient is minus 5 upon 9. For example, 29. In 29, the coefficient is 29 itself. Exercise 69. In this exercise, let us try to write the degree and coefficient of each monomial, 23x cube. Here, 23 is the coefficient and 3 is the degree. 18. Here, 18 is the coefficient and 0 is the degree. Minus 6m raised to 5. Here, minus 6 is the coefficient and 5 is the degree. 11 upon 5y. Here, 11 upon 5 is the coefficient and 1 is the degree. A raised to 2. Here, 1 is the coefficient and 2 is the degree. X. Here, 1 is the coefficient and 1 is the degree. Before we begin, let us quickly revise what do we mean by dividend, divisor, quotient and remainder. For example, if we want to divide 20 by 6, here 20 is called the dividend and 6 is called the divisor. As 6, which is the divisor, when multiplied by 3 gives us 18, which is the nearest smaller number to the dividend, that is 20, the number 3 becomes quotient. And when we subtract the product of the divisor, that is 6, with quotient, that is 3, from dividend, that is 20, we get remainder, that is 2. To check whether the division carried out is correct or not, we always substitute the formula dividend is equal to divisor into quotient plus remainder. Here in our example, 20 is equal to 6 into 3 plus 2. 20 is equal to 18 plus 2. 20 is equal to 20. Therefore, it means that the division carried above is correct. Dividend is equal to divisor into quotient plus remainder exists. You only have to remember two things. 1. The degree of the polynomial of the remainder is always less than the degree of the polynomial of the divisor. 2. The degree of the polynomial of the dividend must be the same or more than the degree of the polynomial of the divisor. Let us see an example of division where we divide a monomial by another monomial. 35x raised to 5 divided by 7x square. This means that when 7x square multiplied by some polynomial will give you 35x raised to 5. Let that some polynomial be a. Therefore, 7x square multiplied by a is equal to 35x raised to 5. So to find a, we divide the coefficient of one monomial along with its variable with the coefficient of the other monomial along with its variable. Let us separate 35x raised to 5 into two parts, that is, 35 and x raised to 5. Similarly, let's separate 7x square into two parts, that is, 7 and x square. Therefore, a is equal to 35 divided by 7 multiplied by x raised to 5 divided by x square. Indices of the polynomials are added in multiplication and subtracted in division. Therefore, a is equal to 5 multiplied by x raised to 5 minus 2 as per the rule of indices, which is equal to 5x raised to 3. Therefore, 7x square into 5x cube is equal to 35x raised to 5. And hence, 35x raised to 5 divided by 7x square is equal to 5x cube. Let us now solve the exercise 80. Fill in the blanks. 1. 21 divided by 7. Here 21 is the dividend and 7 is the divisor. When we say the table of 7, we come across 21 at the third stage. That is, 7 multiplied by 3 is equal to 21. Hence, 3 becomes our quotient, and after subtracting the product of divisor and quotient from the dividend, we get 0, which is our remainder. Hence, 21 divided by 7 is equal to 3. 2. We continue to carry out division until we get remainder 0 or a whole number less than the divisor. Because if we get the remainder greater than the divisor, it means that either the quotient achieved is wrong, or the product of the divisor and the quotient is wrong, or the subtraction of the product of the divisor or the quotient from the dividend is wrong. It means that the division is not correct, and we have still not achieved the answer. Hence, always remember that the remainder should always be smaller than the divisor. 3. Dividend is equal to divisor into quotient plus remainder. 4. When we divide 43 by 5, the quotient is 8 and the remainder is 3. Here, dividend is equal to 43 and the divisor is equal to 5. Therefore, 43 is equal to 5 into 8 plus 3. 5. 5x into some polynomial is equal to 15x raised to 4. Let that some polynomial be a. Therefore, 5x into a is equal to 15x raised to 4. As explained earlier, to find a, we divide the coefficient of one monomial along with its variable with the coefficient of the other monomial along with its variable. Let's separate 15x raised to 4 into two parts. That is, 15 and x raised to 4. Similarly, let's separate 5x into two parts. That is, 5 and x. Therefore, a is equal to 15 divided by 5 multiplied by x raised to 4 divided by x. I hope you remember that when no index is specified in a polynomial, it means 1. Therefore, a is equal to 3 multiplied by x raised to 4 minus 1, which is equal to 3x raised to 3. Therefore, 5x into 3x cube is equal to 15x raised to 4. Let us see some more examples of division of a monomial by another monomial by solving the exercise 81. Question 1. Divide the first polynomial by the second and explain the steps. 1. 21b, 7. This means to divide 21b by 7. This means when 7 multiplied by some polynomial will give you 21b. Let that some polynomial be x. Therefore, 7 multiplied by x is equal to 21b. Solving the equation, we get x is equal to 21b divided by 7, which is equal to 3b. Hence, we can say that 7 multiplied by 3b is equal to 21b. Therefore, 21b divided by 7 is equal to 3b. 2. Minus 30n square, 3n. This means to divide minus 30n square by 3n. This means when 3n multiplied by some polynomial will give you minus 30n square. Let that some polynomial be a. Therefore, 3n into a is equal to minus 30n square. To get a, we divide the coefficient of one monomial along with its variable with the coefficient of the other monomial along with its variable. Let's separate minus 30n square into two parts. That is, minus 30 and n square. Similarly, let's separate 3n into two parts, that is 3 and n. Therefore, a is equal to minus 30 divided by 3 multiplied by n squared divided by n. Therefore, a is equal to minus 10 multiplied by n raised to 2 minus 1, which is equal to minus 10n. Therefore, 3n into minus 10n is equal to minus 30n square. And hence, minus 30n square divided by 3n is equal to minus 10n. 3. 28x raised to 4 minus 7x square. This means to divide 28x raised to 4 by minus 7x square, which is minus 7x square multiplied by some polynomial will give you 28x raised to 4. Let that some polynomial be a. Therefore, minus 7x square into a is equal to 28x raised to 4. The value of a is achieved by dividing the coefficient of one monomial along with its variable with the coefficient of the other monomial along with its variable. Let's separate 28x raised to 4 into two parts, that is, 28 and x raised to 4. Similarly, let's separate minus 7x square into two parts, that is, minus 7 and x square. Therefore, a is equal to 28 divided by minus 7 multiplied by x raised to 4 divided by x raised to 2. Therefore, a is equal to minus 4 multiplied by x raised to 4 minus 2, which is equal to minus 4x square. Therefore, minus 7x square into minus 4x square is equal to 28x raised to 4, and hence 28x raised to 4 divided by minus 7x square is equal to minus 4x square. 4 minus 8y raised to 5 minus y cube. This means to divide minus 8y raised to 5 by minus y cube, which is minus y cube multiplied by some polynomial will give you minus 8y raised to 5. Let that some polynomial be a. Therefore, minus y cube into a is equal to minus 8y raised to 5. I hope you remember indices. As there is no coefficient of y cube, it means 1. Thus, minus 1y cube into a is equal to minus 8y raised to 5. So, we separate minus 8y raised to 5 into two parts, that is, minus 8 and y raised to 5. Similarly, let's separate minus y cube into two parts, that is, minus 1 and y cube. Therefore, a is equal to minus 8 divided by minus 1 multiplied by y raised to 5 divided by y raised to 3. Therefore, a is equal to 8 multiplied by y raised to 5 minus 3, which is equal to 8y square. Therefore, minus y cube into 8y square is equal to minus 8y raised to 5, and hence minus 8y raised to 5 divided by minus y cube is equal to 8y. Let us now solve question 2. Divide the following: 20c squared divided by 15c. This is again very simple. As we have learnt earlier, it means 15c when multiplied by some polynomial will give you 20c square. Let that some polynomial be x. Therefore, 15c into x is equal to 20c square. To get x, we divide the coefficient of one monomial along with its variable with the coefficient of the other monomial along with its variable. That means we separate 20c square into two parts, that is, 20 and c square. Similarly, separating 15c into two parts, that is, 15 and c. Therefore, x is equal to 20 divided by 15 into c squared divided by c. Therefore, reducing we get, therefore, x is equal to 4c divided by 3. Therefore, 15c when multiplied by 4c upon 3 will give you 20c square. Therefore, 20c square divided by 15c is equal to 4c upon 3. Now let's solve question 3. Write 5 different pairs of dividends and divisors such that the quotient in each case is 2x. As the degree of 2x is equal to 1, we have to find such dividends whose degree is 2 or more than 2 whole number. Along with this, it is also necessary to find that divisors whose degree is less than that of the dividend by 1. Therefore, we can easily say that 8x raised to 5 divided by 4x raised to 4 will be equal to 2x raised to 5 minus 4, which is equal to 2x raised to 1, which is equal to 2x. Similarly, the other such pairs can be 1. 4x square divided by 2x. 2. 12x raised to 3 divided by 6x square. 3. 10x raised to 4 divided by 5x cube. 4. Minus 14x raised to 3 upon 3 divided by minus 7x raised to 2 upon 3. I hope you got it. Isn't it very easy to understand? Now let us solve exercise 82, question 2. Divide the binomial by the monomial and write the quotient and the remainder. 1. N square plus 3. N. This means to divide n square plus 3 by n. Here the dividend is a binomial, that is, n square plus 3, and the divisor is a monomial, that is, n. As dividend is equal to divisor into quotient plus remainder. Therefore, n, which is the divisor, when multiplied by some polynomial, that means the quotient should be equal to n square plus 3, which is the dividend. Let's separate the dividend into two parts. While separating a binomial, never forget to separate it along with the sign. Here in our sum, the two parts will be n square and the other is plus 3. To solve this sum, we will divide n square with n, numerator-denominator form. That is, n square upon n. N square means n into n. By reducing we get n, which becomes the first part of our quotient. Now we will write n as the first part of the quotient above the line and the product of n into n, that is the product of the divisor and the quotient, which is equal to n square, exactly below the first part of the dividend. As this n square has no sign, it means it is a positive monomial, and you all know that plus becomes minus and minus becomes plus when we carry out the subtraction. Hence, changing the signs of the polynomial written below the dividend and subtracting it from plus n square, we get 0. Now bring the second part of the dividend, that is plus 3, down for division. Remember, you should always bring the other monomial down for division along with the sign. Never forget to bring down without the sign, else your solution will be wrong. So bringing the second part of the dividend, that is plus 3, down for division, now our dividend becomes 0 plus 3. As we cannot divide 0 plus 3 by n, our division gets completed at this stage. And hence in this sum, n becomes our quotient and 0 plus 3, that is equal to 3, becomes our remainder. 2. 24m raised to 4 minus 16m square, 8m. This means to divide 24m raised to 4 minus 16m square by 8m. Here the dividend is 24m raised to 4 minus 16m square and the divisor is 8m. Let's separate the dividend into two parts, that is, 24m raised to 4 and the other is minus 16m square. Separation should always be along with the sign to avoid further mistake in division. So always separate the dividend with a sign. To solve this sum, we will divide 24m raised to 4 with 8m numerator-denominator form. That is 24m raised to 4 upon 8m, which is but 24 upon 8 into m raised to 4 upon m. By reducing, we get 3 into m raised to 4 minus 1, which is equal to 3m cube. Thus, it becomes the first part of the quotient. Now we will write 3m raised to 3 as the first part of the quotient above the line and the product of 8m and 3m raised to 3, that is the product of the divisor and the quotient, which is equal to 24m raised to 4, exactly below the first part of the dividend. As you all know that this 24m raised to 4 has no sign. It means it is a positive monomial, and therefore we have to change the sign of the monomial written below the dividend for subtraction. Thus, after subtracting minus 24m raised to 4 from plus 24m raised to 4, we get 0. Taking the second part of the dividend down for division, that is minus 16m square as per our separation, now our dividend becomes 0 minus 16m square. Now we will divide minus 16m square with 8m numerator-denominator form. That is minus 16m square upon 8m, which is minus 16 upon 8 into m square upon m. By reducing, we get minus 2 into m raised to 2 minus 1, which is equal to minus 2m. Thus, it becomes the second part of the quotient. Now we will write minus 2m as the second part of the quotient above the line and the product of 8m and minus 2m, that is the product of the divisor and the quotient, which is equal to minus 16m square, exactly below the second part of the dividend. As you all know that this minus 16m square, which is written below the dividend, has a minus sign. We have to change its sign to positive for subtraction. Thus, after subtracting plus 16m square from minus 16m square, we get 0. And hence, the quotient of our sum is 3m cube minus 2m, and the remainder of our sum is 0. Now let us solve exercise 82, question 3. Divide. Open bracket 18p raised to 7 plus 15p raised to 5, close bracket, divided by 3p raised to 4. This is again the same type of sum as we have solved earlier. Here the dividend is 18p raised to 7 plus 15p raised to 5 and the divisor is 3p raised to 4. Let us separate the dividend into two parts, that is 18p raised to 7 and the other is plus 15p raised to 5. To solve this sum, we will divide 18p raised to 7 with 3p raised to 4, numerator-denominator form. That is 18p raised to 7 upon 3p raised to 4, which is 18 upon 3 into p raised to 7 upon p raised to 4. By reducing, we get 6 into p raised to 7 minus 4, which is equal to 6p cube, which thus becomes the first part of our quotient. Now we will write 6p raised to 3 as the first part of the quotient above the line and the product of 3p raised to 4 and 6p cube, that is the product of the divisor and the quotient, which is equal to plus 18p raised to 7, exactly below the first part of the dividend. As you all know that this 18p raised to 7 has no sign, it means it is a positive monomial, and therefore we have to change the sign of the monomial written below the dividend for subtraction. Thus, after subtracting minus 18p raised to 7 from plus 18p raised to 7, we get 0. Taking the second part of the dividend down for division, that is plus 15p raised to 5, now our dividend becomes 0 plus 15p raised to 5. Now we will divide plus 15p raised to 5 with 3p raised to 4. Numerator-denominator form. That is, plus 15p raised to 5 upon 3p raised to 4, which is but 15 upon 5 into p raised to 5 upon p raised to 4. By reducing, we get 5 into p raised to 5 minus 4, which is equal to 5p raised to 1, which is equal to 5p, and our second part of our quotient. Now we will write plus 5p as the second part of the quotient above the line and the product of 3p raised to 4 and plus 5p, that is the product of the divisor and the quotient, which is equal to plus 15p raised to 5, exactly below the second part of the dividend. As you all know that we have to change the sign for subtraction, thus after changing the sign and subtracting minus 15p raised to 5 from 15p raised to 5, we get 0. And hence the quotient of our sum is 6p cubed plus 5p. And the remainder of our sum is 0. Now let us solve exercise 83 question 1, divide. Write the quotient and the remainder. Open bracket m cube plus m square plus m close bracket divided by m. Here the dividend is m cube plus m square plus m and the divisor is m. This is again the same type of sum as we have solved earlier, but the only difference is we have to separate the dividend into 3 halves instead of 2 halves. That is m cube plus m square and plus m. To solve this sum, we will divide m cube with m, numerator-denominator form. That is m cube upon m. As m in the denominator has no index, it means 1. Hence, m cube upon m is equal to m raised to 3 minus 1, which is equal to m square, and that becomes the first part of the quotient. Now we will write m square as the first part of the quotient above the line and the product of m and m square, that is the product of the divisor and the quotient, which is equal to plus m cube, exactly below the first part of the dividend. Changing the signs and subtracting minus m cube from plus m cube, we get 0. Taking the second part of the dividend down for division, that is plus m square, now our dividend becomes 0 plus m square. Now we will divide plus m square with m, numerator-denominator form, that is plus m square upon m. As m in the denominator has no index, it means 1. Hence, plus m square upon m is equal to plus m raised to 2 minus 1, which is equal to plus m raised to 1, which is equal to plus m, and that becomes the second part of the quotient. Now we will write plus m as the second part of the quotient above the line and the product of m and plus m, that is the product of the divisor and the quotient, which is equal to plus m square, exactly below the second part of the dividend. Changing the signs and subtracting minus m square from plus m square, we get 0. Taking the third part of the dividend down for division, that is plus m, now our dividend becomes 0 plus m. Now we will divide plus m with m, numerator-denominator form, that is plus m upon m. As m in the numerator as well as in the denominator has no index, it means 1. Hence, plus m upon m is equal to plus m raised to 1 minus 1, which is equal to plus m raised to 0, which is equal to plus 1, and that becomes the third part of the quotient. Now we will write plus 1 as the third part of the quotient above the line and the product of m and plus 1, that is the product of the divisor and the quotient, which is equal to plus m, exactly below the third part of the dividend. Changing the signs and subtracting minus m from plus m, we get 0. And hence, the quotient of our sum is m square plus m plus 1. And the remainder of our sum is 0. 2. Open bracket 7x raised to 4 minus 21x square plus 6, close bracket, divided by 7x square. Here the dividend is 7x raised to 4 minus 21x square plus 6 and the divisor is 7x square. As learnt now, we will separate the dividend into 3 halves, that is 7x raised to 4 minus 21x square and plus x. To solve this sum, we will divide 7x raised to 4 with 7x raised to 2, numerator-denominator form, that is 7x raised to 4 upon 7x raised to 2, which is 7 upon 7 into x raised to 4 upon x raised to 2. By reducing, we get 1 into x raised to 4 minus 2, which is equal to x square, which becomes the first part of the quotient. Now we will write x square as the first part of the quotient above the line and the product of 7x raised to 2 and x square, that is the product of the divisor and the quotient, which is equal to 7x raised to 4, exactly below the first part of the dividend. As you all know that this 7x raised to 4 has no sign, it means it is a positive monomial and therefore we have to change the sign of the monomial written below the dividend for subtraction. Thus, after subtracting minus 7x raised to 4 from plus 7x raised to 4, we get 0. Taking the second part of the dividend down for division, that is minus 21x square, now our dividend becomes 0 minus 21x square. To solve this sum, we will divide minus 21x square with 7x raised to 2, numerator-denominator form, that is minus 21x square upon 7x raised to 2, which is minus 21 upon 7 into x raised to 2 upon x raised to 2. By reducing, we get minus 3 into x raised to 2 minus 2, which is equal to minus 3x raised to 0, which is equal to minus 3, which thus becomes the second part of our quotient. Now we will write minus 3 as the second part of the quotient above the line and the product of 7x raised to 2 and minus 3, that is the product of the divisor and the quotient, which is equal to minus 21x square, exactly below the second part of the dividend. Changing the sign of the monomial written below the dividend for subtraction, and after subtracting plus 21x square from minus 21x square, we get 0. Taking the third part of the dividend down for division, that is plus 6. Now our dividend becomes 0 plus 6. As we cannot divide 6 by 7x square, our division gets complete here. And hence the quotient of the sum is x square minus 3. And the remainder of our sum is 0 plus 6, that is equal to 6. Question 2. Divide the trinomial by the monomial. Write the answer in the form of dividend is equal to divisor into quotient plus remainder. 6y square minus 18y plus 7, 3y. Here the dividend is 6y square minus 18y plus 7 and the divisor is 3y. As learnt now, we will separate the dividend into 3 halves, that is 6y raised to 2 minus 18y and plus 7. To solve this sum, we will divide 6y raised to 2 with 3y, numerator-denominator form, that is 6y raised to 2 upon 3y, which is 6 upon 3 into y raised to 2 upon y. By reducing, we get 2 into y raised to 2 minus 1, which is equal to 2y raised to 1, that is 2y, and thus the first part of the quotient. Now we will write 2y as the first part of the quotient above the line and the product of 3y and 2y, that is the product of the divisor and the quotient, which is equal to 6y raised to 2, exactly below the first part of the dividend. As you all know that this 6y raised to 2 has no sign, it means it is a positive monomial, and therefore we have to change the sign of the monomial written below the dividend for subtraction. Thus, After subtracting minus 6y raised to 2 from plus 6y raised to 2, we get 0. Taking the second part of the dividend down for division, that is minus 18y, now our dividend becomes 0 minus 18y. To solve this sum, we will divide minus 18y with 3y, numerator-denominator form. That is minus 18y upon 3y, which is minus 18 upon 3 into y upon y. By reducing, we get minus 6 into y raised to 1 minus 1, which is equal to minus 6y raised to 0, which is equal to minus 6, which thus becomes the second part of our quotient. Now we will write minus 6 as the second part of the quotient above the line, and the product of 3y and minus 6, that is, the product of the divisor and the quotient, which is equal to minus 18y, exactly below the second part of the dividend. Changing the sign of the monomial written below the dividend for subtraction, and after subtracting plus 18y from minus 18y, we get 0. Taking the third part of the dividend down for division, that is plus 7, now our dividend becomes 0 plus 7. As we cannot divide 7 by 3y, our division gets complete here, and hence the quotient of our sum is 2y minus 6, and the remainder of our sum is 0 plus 7, that is equal to 7. As we have to write our answer in the form of dividend is equal to divisor into quotient plus remainder, therefore 6y square minus 18y plus 7 is equal to 3y into the whole 2y minus 6 plus 7. Now let us solve exercise 84, question 1. Divide the polynomial by the binomial. Write your answer in the form dividend is equal to divisor into quotient plus remainder. Before we start this exercise, I would like to tell certain very important points that has to be remembered while solving this exercise. 1. As we have to divide a polynomial by a binomial divisor, we have to take a binomial part of the polynomial dividend for division. Always remember that the product of a binomial with a quotient will always be a binomial. 2. If the dividend is not in a proper sequence of their index, that is, suppose you have a dividend as x raised to 3 plus x plus 2, here x raised to 2, that means x square is missing after x raised to 3. In such a case, you will insert a 0x square in the dividend after x raised to 3. In other words, the dividend should always be in the descending order of their index. And hence, here our dividend in such a case will become x raised to 3 plus 0x square plus x plus 2. Let us now begin with the exercise. 1. X square minus 7x plus 12, x minus 3. Here our dividend is x square minus 7x plus 12, and our divisor is a binomial, that is x minus 3. When a divisor is a binomial, we will separate the divisor into two parts, that is x and the other as minus 3 to carry out the division. So now we will divide the first term of the dividend, that is x square, by the first part of the divisor x, that is x square upon x, which is equal to x raised to 2 minus 1 as per the rule of the indices, which is equal to x raised to 1, and that is equal to x, first part of the quotient. Now we will write x as the first part of the quotient above the line. After this, we will multiply the quotient we got, x, with the divisor, that is x minus 3. As x multiplied by x minus 3 is equal to x square minus 3x, we will now write this product exactly below that part of the dividend whose polynomials have the same index. Thus, we will write x square below x square and minus 3x below minus 7x. Now, after changing the signs of both the terms of the product, we get 0 minus 4x. Now we shall bring the third part of the dividend, that is plus 12, down for division. Thus now the dividend becomes minus 4x plus 12. Again, as done in the first step, now we shall divide the first term of our dividend, that is minus 4x, with the first part of our divisor, that is x. That is minus 4x upon x, which is equal to minus 4x raised to 1 minus 1. As per the rule of the indices, which is equal to minus 4x raised to 0, that is minus 4, and the second part of our quotient. I hope you remember any polynomial raised to 0 is equal to 1. Now we will write minus 4 as the second part of the quotient above the line. After this, we will multiply the quotient we got, that is minus 4, with the divisor, that is x minus 3. As minus 4 multiplied by x minus 3 is equal to minus 4x plus 12, we will now write this product exactly below that part of the dividend having the same index. Thus, we will write minus 4x below minus 4x and plus 12 below plus 12. Now, after changing the signs of both the terms of the dividend, we get 0. As there is no other polynomial to be brought down for division, our division gets over here itself, and hence the quotient of our sum becomes x minus 4, and the remainder of our sum becomes 0. As we have to write our answer in the form of dividend is equal to divisor into quotient plus remainder, therefore, x square minus 7x plus 12 is equal to x minus 3 in one bracket and x minus 4 in other bracket plus 0. 2. 5a minus 12 plus 3a square minus 5a cube plus 6a raised to 4. A square minus 1. As you can see that the dividend is not in a proper sequence of index, we have to first arrange it in a descending order, that is, from big to small, as explained earlier. Arrange the terms in descending order with the sign. Don't forget to shift the term with a sign. And hence our arranged dividend is 6a raised to 4 minus 5a cube plus 3a square plus 5a minus 12. Here our dividend is 6a raised to 4 minus 5a cube plus 3a square plus 5a minus 12. And our divisor is a binomial, that is a square minus 1. As a divisor is a binomial, we will separate the divisor into two parts, that is a square and the other as minus 1 to carry out our division. So now we will divide the first term of the dividend, that is 6a raised to 4, by the first part of the divisor, that is a square, that is 6a raised to 4 upon a square, which is equal to 6a raised to 4 minus 2, as per the rule of the indices, which is equal to 6a raised to 2, and this becomes the first part of the quotient. Now we will write 6a square as the first part of the quotient above the line. After this, we will multiply the quotient, that is 6a square, with the divisor, that is a square minus 1. As 6a square multiplied by a square minus 1 is equal to 6a raised to 4 minus 6a square, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write 6a raised to 4 below 6a raised to 4 and minus 6a square below plus 3a square. Now after changing the signs of both the terms of the product, we get 0 plus 9a square. Now we shall bring the second term of the dividend down for division, that is, minus 5a cube. Thus, now our dividend becomes minus 5a cube plus 9a square. Again, as done in the first step, now we shall divide the first term of our dividend, that is, minus 5a cube, with the first part of our divisor, that is, a square. That is, minus 5a cube upon a square, which is equal to minus 5a raised to 3 minus 2 as per the rule of the indices, which is equal to minus 5a raised to 1, that is minus 5a, and thus the second part of our quotient. Now we will write minus 5a as the second part of the quotient above the line. After this, we will multiply the quotient, that is minus 5a, with the divisor, that is a square minus 1. As minus 5a multiplied by a square minus 1 is equal to minus 5a cube plus 5a, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write minus 5a cube below minus 5a cube and plus 5a below plus 5a. Now, after changing the signs of both the terms of the product, we get 0. Now we shall bring 9a square along with that term of the dividend down for division, which is still pending, that is, minus 12. Thus, now our dividend becomes plus 9a square minus 12. Again, as done earlier, now we shall divide the first term of our dividend, that is, plus 9a square, with the first part of our divisor, that is, a square. That is, plus 9a square upon a square, which is equal to plus 9a raised to 2 minus 2, as per the rule of the indices, which is equal to plus 9a raised to 0, that is, plus 9. And thus the third part of our quotient. Now we will write plus 9 as the third part of the quotient above the line. After this we will multiply the quotient, that is plus 9, with the divisor, that is a square minus 1. As plus 9 multiplied by a square minus 1 is equal to 9a square minus 9, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write 9a square below 9a square and minus 9 below minus 12. Now after changing the signs of both the terms of the product, we get 0 minus 3. As there is no other polynomial to be brought down for division, our division gets over here itself. And hence the quotient of our sum becomes 6a square minus 5a plus 9. And the remainder of our sum becomes minus 3. As we have to write our answer in the form of dividend is equal to divisor into quotient plus remainder, therefore 6a raised to 4 minus 5a cube plus 3a square plus 5a minus 12 is equal to a square minus 1 in one bracket and 6a square minus 5a plus 9 in other bracket, plus the remainder, that is minus 3 in the third bracket. 3. b raised to 4 minus 12b square, b square plus 1. Here our dividend is b raised to 4 minus 12b square and the divisor is a binomial, that is b square plus 1. As a divisor is a binomial, we will separate the divisor into two parts, that is b square and the other as plus 1 to carry out the division. So now we will divide the first term of the dividend, that is b raised to 4, by the first part of our divisor, that is b square. That is b raised to 4 upon b square, which is equal to b raised to 4 minus 2, as per the rule of the indices, which is equal to b raised to 2, and thus the first part of our quotient. Now we will write b square as the first part of the quotient above the line. After this, we will multiply the quotient, that is b square, with the divisor, that is b square plus 1. As b square multiplied by b square plus 1 is equal to b raised to 4 plus b square, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus, we will write b raised to 4 below b raised to 4 and b square below minus 12b square. Now, after changing the signs of both the terms of the product, we get 0 minus 13b square. Now we shall bring plus 0 down for division. Thus now our dividend becomes minus 13b square plus 0. Again, as done earlier, now we shall divide the first term of our dividend, that is minus 13b square, with the first part of the divisor, that is b square. That is minus 13b square upon b square, which is equal to minus 13b raised to 2 minus 2, as per the rule of the indices, which is equal to minus 13b raised to 0, that is minus 13, and the second part of the quotient. Now we will write minus 13 as the second part of the quotient above the line. After this, we will multiply the quotient, that is minus 13, with the divisor, that is b square plus 1. As minus 13 multiplied by b square plus 1 is equal to minus 13b square minus 13, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write minus 13b square below minus 13b square and minus 13 below plus 0. Now, after changing the signs of both the terms of the product, we get 0 plus 13. Therefore, the quotient of sum is b square minus 13, and the remainder is equal to plus 13. Therefore, b raised to 4 minus 12b square is equal to b square plus 1 in one bracket and b square minus 13 in other bracket plus 13. 4n minus 4n square plus n raised to 5 minus n raised to 4. n cube minus 4. First of all, arrange the dividend in a descending order. That is, n raised to 5 minus n raised to 4 minus 4n square plus 4n. Here the dividend is n raised to 5 minus n raised to 4 minus 4n square plus 4n, and our divisor is a binomial, that is n cube minus 4. As a divisor is a binomial, we will separate the divisor into two parts, that is n cube and the other as minus 4 to carry out our division. So now we will divide the first term of the dividend, that is n raised to 5, by the first part of our divisor, that is n cube. That is n raised to 5 upon n cube, which is equal to n raised to 5 minus 3, as per the rule of the indices, which is equal to n raised to 2, and this becomes the first part of our quotient. Now we will write n square as the first part of the quotient above the line. After this, we will multiply the quotient, that is n square, with the divisor, that is n cube minus 4, as n square multiplied by n cube minus 4 is equal to n raised to 5 minus 4n square. We will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write n raised to 5 below n raised to 5 and minus 4n square below minus 4n square. Now after changing the signs of both the terms of the product, we get 0. Now bringing the second and the last term of the dividend down for division, now the dividend becomes minus n raised to 4 plus 4n. So now we will divide the first term of the dividend, that is minus n raised to 4, by the first part of our divisor, that is n cube, that is minus n raised to 4 upon n cube, which is equal to minus n raised to 4 minus 3, as per the rule of the indices, which is equal to minus n raised to 1, that is minus n. And this becomes the second part of our quotient. Now we will write minus n as the second part of the quotient above the line. Then we will multiply the quotient, that is minus n, with the divisor, that is n raised to 3 minus 4. As minus n multiplied by n cube minus 4 is equal to minus n raised to 4 plus 4n, we will now write this product exactly below that part of the dividend whose polynomial bears the same index. Thus we will write minus n raised to 4 below minus n raised to 4 and plus 4n below plus 4n. Now after changing the signs of both the terms of the product, we get 0. Therefore, n raised to 5 minus n raised to 4 minus 4n square plus 4n is equal to n raised to 3 minus 4 in one bracket and n square minus n in other bracket plus 0. What do we mean by factors of polynomials? Factors of polynomials means the element of the polynomial. Remember, if a sign is not mentioned before a polynomial, it means it is a positive polynomial. Working with positive polynomial is very simple, but we have to be very careful with signs while considering a negative polynomial. To learn this chapter, we must be very careful with the signs in multiplication, that is, plus and minus. Plus into plus is equal to plus. Minus into minus is equal to plus. Minus into plus is equal to minus. Plus into minus is equal to minus. In short, in multiplication, the product of the same sign is positive and the product of opposite sign is negative. Let us solve certain examples of factorization from the revision exercise. 1. 3m square plus 6mn. In this sum, we need not worry about the signs as both the terms of the polynomials are positive. There are certain elements which are common in both the terms of this polynomial. In 3m square plus 6mn, here m is common in both the terms, that is 3m square as well as 6mn. And along with this, the number 3 is also common, as 3 is factor of 3 as well as 6. So in the above expression, after taking 3m as common, we will open the bracket and write that variable which when multiplied by 3m gives us the first term 3m square, and that variable is m, because 3m into m is equal to 3m square. As there exists a plus sign in between the two terms, we shall also put a plus sign. Similarly, we should find such a variable which when multiplied by 3m gives us the second term 6mn, and that variable is 2n, because 2n into 3m gives us 6mn. Hence, the factor of 3m square plus 6mn is equal to 3m open bracket m plus 2n close bracket. 2. 7a plus 14b minus 21c. In this sum, we have to be little careful as the trinomial is made up of positive as well as negative monomials. Note: if you take a common factor as positive, then the signs between the terms remain unchanged. But if you take the common factor as negative, all the signs of the uncommon factor inside the bracket will change. That means plus will become minus and minus will become plus. In this sum, we can see that the variables are different in all the three terms of the trinomial. But there is something common in their coefficient, that is 7, 14 and 21. And that is the number 7. We shall take 7 as the common factor. Remember, we will take plus 7 as common and not minus 7, and hence the signs between the terms will not change. Hence, we shall write 7 open bracket plus a, because 7 multiplied by plus a gives us plus 7a, plus 2b, because 7 multiplied by plus 2b gives us plus 14b, minus 3c, as 7 multiplied by minus 3c gives us minus 21c, and then close the bracket. Hence, the factor of 7a plus 14b minus 21c is equal to 7 open bracket a plus 2b minus 3c close bracket. 3. 4x cubed plus 2x square plus 2x plus 1. As said earlier, all the terms are positive, so the signs will remain unchanged. In this sum, we will take the first two terms together, that is 4x cubed plus 2x square, followed by the next two terms together, that is 2x plus 1. For the first two terms, 2x square is common in both. Hence, taking 2x square as common, we will write the uncommon factor. 2x square open bracket 2x, because 2x multiplied by 2x square gives us 4x cubed, plus 1 because 2x square multiplied by 1 gives us 2x square close bracket. Now for the next two terms, that is 2x plus 1. Here we shall take plus 1 as common. Hence, we will write the factor of these two terms as plus 1 open bracket 2x, because 2x multiplied by plus 1 gives you plus 2x plus 1, as 1 multiplied by plus 1 gives you 1 close bracket. Hence, the factors of 4x cubed plus 2x square plus 2x plus 1 is equal to 2x square into 2x plus 1 into 2x plus 1. As the uncommon factor 2x plus 1 appears twice, we shall write it only once along with the common factors, which means 2x square plus 1 into 2x plus 1. Hence, the factors of 4x cubed plus 2x square plus 2x plus 1 is equal to 2x square plus 1 and 2x plus 1. 4. X square minus 9x plus 11x minus 99. Again here, we will take the common factors for the first and the second term together, and then the common factor for the third and the fourth term together. We will have to be careful while taking the common factors, as the monomials are positive as well as negative. For the first and the second term, x square minus 9x, taking plus x common, we get plus x into x minus 9. For the third and the fourth term, plus 11x minus 99, taking plus 11 common, we get plus 11 into x minus 9. Hence, the factors of x square minus 9x plus 11x minus 99 is equal to x into x minus 9 plus 11 into x minus 9, which means x plus 11 in one bracket and x minus 9 in the other bracket. Hence, the factors of x square minus 9x plus 11x minus 99 is equal to x plus 11 and x minus 9. 5. X square plus 13x minus 11x minus 143. For the first and the second term, x square plus 13x taking plus x common, we get plus x into x plus 13. For the third and the fourth term, minus 11x minus 143 taking minus 11 common, we get minus 11 into x plus 13. Remember, taking a negative common factor changes the signs of the uncommon factor inside the bracket, and hence plus x into minus 11 gives us minus 11x, and plus 13 into minus 11 gives us minus 143. Hence, the factors of x square plus 13x minus 11x minus 143 is equal to x into x plus 13 into minus 11 into x plus 13, which means x minus 11 in one bracket and x plus 13 in the other bracket. Hence, the factors of x square plus 13x minus 11x minus 143 is equal to x minus 11 and x plus 13. 6. 4a square minus 9b square. As we see, 4 is the square of 2 and 9 is the square of 3. We can write 4a square as 2a the whole square minus 9b square as 3b the whole square. I hope you remember what is a plus b into a minus b. A plus b into a minus b is equal to a square minus b square. Therefore, in our sum, a will be 2a the whole square and b will be 3b the whole square. Now, substituting the value of a and b, we get 2a plus 3b in one bracket and 2a minus 3b in other bracket. Therefore, 4a square minus 9b square is equal to 2a plus 3b and 2a minus 3b. Now we shall learn the factorization of polynomials by the expansion method. 1. X square plus 5x plus 6. I hope you all remember, while factorizing a given trinomial, we should look for two factors of the product, first term into the last term, such that their sum is equal to the middle term. In this x square plus 5x plus 6, the product of the first term and the last term is x square into 6, which is equal to 6x square. We should expand 6x square in such a way that their sum is equal to the middle term. 6x square can be expanded as 2x into 3x, as their sum is equal to the middle term, that is 5x, and their product is equal to the product of the first term into the last term, that is 6x square. Therefore, x square plus 5x plus 6 can be written as x square plus 2x plus 3x plus 6. After expanding, we have to take the common of the first two terms followed by the common of the next two terms. For the first and the second term, x square plus 2x taking plus x common, we get plus x into x plus 2. For the third and the fourth term, plus 3x plus 6 taking plus 3 common, we get plus 3 into x plus 2. Therefore, it means x plus 2 in one bracket and x plus 3 in the other bracket. Hence, the factors of x square plus 5x plus 6 is equal to x plus 2 and x plus 3. Let us study about positive and negative polynomials. 1. 12x square plus 7x minus 10. The product of the first term and the last term is 12x square into minus 10, which is equal to minus 120x square. 120x square can be expanded as plus 15x and minus 8x, as their sum is plus 7x, which is the middle term. As our middle term is positive, we will give positive sign to our bigger factor. That is why here we have given positive sign to 15 and negative sign to 8x. Then solve the sum further by taking the common factor as taught earlier. 3x into 4x plus 5 minus 2 into 4x plus 5. Here, please keep in mind that if there is a negative sign outside the bracket, we will change the sign inside the bracket. You can see here we have taken 4x plus 5 and not 4x minus 5. Remember to take care of the signs. Hence, the factors of 12x square plus 7x minus 10 is equal to 3x minus 2 in one bracket and 4x plus 5 in other bracket. Let us solve exercise 85, question 2, sum number 1. 11x square minus 18x plus 7. I hope you remember. While factorizing a given trinomial, we should look for two factors of the product, first term into the last term, such that their sum is equal to the middle term. Here the middle term is minus 18x. So we should look for the two factors whose product is equal to the product of the first term and the last term of the trinomial. That is 11x square into 7, that is 77x square, and whose sum is equal to the middle term, that is minus 18x. Therefore, we can write minus 18x as minus 11x and minus 7x. Therefore, we can say that 11x square minus 18x plus 7 is equal to 11x square minus 11x minus 7x plus 7. Considering the first two terms and finding the common factor, we get 11x into x minus 1. Now, considering the next two terms and finding the common factor, we get 7 into x minus 1. 11x into x minus 1 minus 7 into x minus 1, which is equal to 11x minus 7 in one bracket and x minus 1 in other bracket. Hence, 11x square minus 18x plus 7 is equal to 11x minus 7 in one bracket and x minus 1 in other bracket. Now let us solve sum number 2. 3x square plus 3x minus 1260. In this sum, we shall take 3 common, as 3 is a common factor in all the 3 terms of the polynomial, simply for the reason that finding our factor becomes easy. Therefore, we get 3 into x square plus x minus 420. Expanding further, we get 3 into x square plus 21x minus 20x minus 420, which is equal to 3 open big bracket x open small bracket x plus 21 close small bracket minus 20 open small bracket x plus 21 close small and big bracket, which is equal to 3 into x minus 20 in one bracket and x plus 21 in other bracket. Hence, 3x square plus 3x minus 1260, which is equal to 3 into x minus 20 and x plus 21. Let us now learn a very important formula, that is, a cube plus b cube is equal to a plus b in one bracket and a square minus ab plus b square in other bracket. Let us solve exercise 86. 1. 27m cube plus 125n cube. As you know, the cube root of 27 is 3 and that of 125 is 5. Thus we can say that 27m cube plus 125n cube is 3m the whole cube plus 5n the whole cube. Now, substituting the values of a and b in the formula, we get which is equal to 3m plus 5n in one bracket and 3m the whole square minus 3m into 5n plus 5n the whole square in other bracket, which is equal to 3m plus 5n in one bracket and 9m square minus 15mn plus 25n square in other bracket. Therefore, 27m cube plus 125n cube is equal to 3m plus 5n and 9m square minus 15mn plus 25n square. 2. P cube plus 64q cube. As you know, the cube root of 64 is 4. Thus, we can say that p cube plus 64q cube is p cube plus 4q the whole cube. Consider p as a and 4q as b and substitute the value of a and b in the formula of a cube plus b cube, which is equal to p plus 4q in one bracket and p square minus p into 4q plus 4q the whole square in other bracket, which is equal to p plus 4q in one bracket and p square minus 4pq plus 16q square in other bracket. Now we shall solve the sums based on the formula. A cube minus b cube is equal to a minus b in one bracket and a square plus ab plus b square in other bracket. Let us begin with sum number 1 from exercise 87. 1. X cube minus 8y cube. We have substituted the formula of a cube plus b cube. Similarly, let us substitute the formula of a cube minus b cube. First, let us take the cube root of x cube and 8y cube. We get x cube minus 2y the whole cube. Now we will take a is equal to x and b is equal to 2y. Substituting the values of a and b in the formula, we get x minus 2y in one bracket and x the whole square plus x into 2y plus 2y the whole square in other bracket, which is equal to x minus 2y in one bracket and x square plus 2xy plus 4y square in other bracket. Hence, x cube minus 8y cube is equal to x minus 2y and x square plus 2xy plus 4y square.